Mr. Strauss's chemistry class is filmed before a live studio audience. No laugh track or applause have been added in. All of it is real except the fame. Okay.
Hey Jack, Chochi, Jack, Kevin, hey.
Alright. Alright. So,
not the right class to do.
now, today we're going to learn about empirical formulas and molecular formulas. An empirical formula is the simplest ratio. Why don't you film something useful like chemistry? Okay, so the empirical formula is the simplest ratio of elements in a compound.
That's the simplest.
Yeah, isn't that how you spell it?
Simpler.
Not at all.
The simplest.
Oh, babe.
Isn't it just like P-L-E-S-T?
You are.
The simplest.
UST.
Or most simple.
That doesn't look right.
It's definitely not simplest.
I bet you it is.
You want? Should I call him right now?
Can
Can I
I
call
look
him
it
now?
No, go ahead and look it up.
No, I definitely just did it, and it's S-I-M-P-L-E-S-T.
Okay, all right. So,
Oh.
empirical formula is the simplest ratio of elements in a compound. So, the molecular formula is the actual formula. I don't know if you just saw that, but I think we said a new YouTube first. A chemistry teacher being filming himself teaching chemistry.
Wait, who's the
They're out in the hallway.
Who?
Filming me, filming myself.
Wait, no, they're
Currently?
filming it right now?
They were filming me teaching.
Wow.
There you
That's
go.
nice.
A new YouTube first. Filming someone, filming themselves, teaching chemistry before a live studio audience. Okay, empirical formula, simplest ratio of elements in a compound. Molecular formula is the actual formula. Okay, so let's calculate empirical formula first, then we'll do a molecular formula. So the problem I want to do is where I've got an unknown compound that has got 93.8% carbon and 6.25% hydrogen. So list everything in your compound, list them vertically, then write their percentages. So whatever my compound is, it's got 93.8% carbon, 6.25% hydrogen.
You're not in the screen.
I don't need to be in the screen.
Oh,
So, I take my percentages and I convert them to grams.
Oh, pen.
And then you divide each by their molar masses. Carbon is 12, hydrogen is 1.01, and this will give us a molar ratio, which comes out to be 7.82 and 6.19. Now, this ratio is kind of like saying for every 7.82 carbons, there's 6.19 hydrogens. That's not very helpful. What we like to have is nice whole number ratios. So how do I get it to be in nice whole number ratios?
Found.
What you do is you take the smallest one and you divide by the smallest one. So 6.19 is smaller. And I get this. But this isn't a nice whole number ratio either. That's like saying for every 1.25 carbons, there's one hydrogen. We want nice whole number ratios.
2, 6.
So how can I get to have nice whole number ratios? Well, if one of them ends in approximately 0.25, multiply them both by 4, and you get that. Now we have the empirical formula. C5H4. Again, that is the simplest ratio of elements in the compound. So basically, to give you an analogy here, Ben, that's like saying I had a chemistry party this weekend. At my chemistry party, I had 5 guys and 4 girls were at my, the ratio.
Bad ratio.
The ratio is 5 guys and 4 girls.
Bad ratio.
Okay? Does it tell you, if this is just the ratio, does it tell you how many people were actually at my party? No. For every 5 guys at the party, there were 4 girls. That's the ratio. It doesn't actually tell you how many people were there. It could have been 500 guys and 400 girls at my party. The ratio is 5 to 4. So what we want to do then is calculate the actual formula, the molecular formula. So we're going to do another problem to do that. So we're going to do number 68 in the book. According to number 68, I have an unknown compound, and this unknown compound is got 3 elements in it. It's got 26.7 grams of phosphorus, 12.1 grams of nitrogen, and 61.2 grams of carbon. So just like the last problem, the first thing you do is find the empirical formula, find the basic ratio. So I go ahead, Emma, and I divide by all of their molar masses. So phosphorus is
30.97.
31. Nitrogen is 14.0. Carbon is 12.0. Except I don't think it's carbon, I actually think it's chlorine. Yes, chlorine. Sorry. Then I do my division to get my molar ratios. Now what's my next step? Divide by the smallest one. So 0.861, 0.861, 0.861. That's 1, that's approximately 1, and that's approximately 2. Now, do we need to multiply by anything here?
No.
No. But if, let's say one of them ended in 0.25, we'd multiply it by 4. If one of them ended in 0.33, we'd multiply them all by 3, and if one ended in 0.5, we'd multiply it by 2. Okay? But since none of them do, we've got our empirical formula, just like we did in the previous problem. We've got P1, N1, Cl2. That's my empirical formula. Now, how do I calculate the real formula, the molecular formula? In order to do that, you have to be given some more information. And if you go back to problem number 68, it will tell you that the molecular mass is 695 AMUs. So you have to be given the molecular mass, Lexi, otherwise you can't figure it out. So what I do here is I take the empirical mass times some number, let's call it x, is equal to the molecular mass. So I can find the empirical mass from my empirical formula. So phosphorus is 31.0 times 1. Nitrogen is 14.0 times 1. Chlorine is 35.5 times 2. When I add that all up, I end up with, I believe, let's just 116. That's what I thought. AMUs. So there's my empirical mass. So 116 AMUs times some number x is going to equal my molecular mass, which is 695. Then I solve for x. And I get approximately 6. So what this number is, Molly, is what I'm going to go back and multiply my empirical formula by. So I take that 6, I multiply it by my empirical formula, and I get P6, N6, Cl12. This is the molecular formula. This is the real formula. So there's my molecular formula, P6N6Cl12. That's the actual formula. The empirical would be P1N1Cl2. So like I said, the empirical gives you the simplest ratio of the elements, but it doesn't tell you the actual formula.
So, if there was like a chem party, there would be like 6 people, or like 6 girls, 6 guys, and like 12 like animals or something.
Sure.
Like total?
12
Like it's not
points.
like.
Yep. Total. This would be the actual number. Any other questions? So then your homework tonight is 23 through 26 and 27 through 31 on pages 89 and 90. We will do them on, we'll go over them on Monday because tomorrow we're going to be doing our manganese lab.
Particular that are on science Something else.